Hey guys, today we're going to be solving Leetcode question 417 Pacific Atlantic water flow. This is a depth first search or a breadth first search question. Uh, it's a lengthy question. Also, understanding the question is not as easy because, it does not align with the natural way of thinking, at least for me. So basically, you're given a 2D array of cell values where every value represents the height of, say, walls or something. Uh, okay, they're just cells of some height. Let's say, let's just copy paste this. Okay, so you have a matrix with cell values which have some heights, and the matrix is covered on the left and the top by the Pacific Ocean and by the Atlantic Ocean on the right and the bottom sides. Now you have to return the grid values or the cell numbers, um, which you can from. You have to return the cell values starting from which you can reach both the Pacific Ocean and the Atlantic Ocean. Now the constraint is that when you start from a cell value, you can only travel in directions where the value where the height is decreasing, meaning let's say phi. Now you can only move up, down, left, or right. So from phi you can move to 3 because the height is lesser than, because 3 is lesser than phi, you can only move from a higher height to a lower height. So you can move from phi to 3 to 1, and thus you have reached the Atlantic Ocean. Or you can move from phi to 1 to 1, and then you again reach the Atlantic Ocean. Or you can move from phi to 1, you cannot move to 4 because you can never move from a lower value to a higher height value. Similarly, you can't move from phi to 1 to 1 to 2. Okay, so now we have seen that we can reach the Atlantic Ocean starting from phi. um, I don't know how it works. Like, how does water start generating from some value inside the matrix? But let's not get into the logistics of that. Let's just understand what the question is asking. So let's just assume that water can start generating from any cell um, in this grid, and you just have to check to which oceans the water can flow to. And the water can only flow from a cell of higher height to a cell of lower height. Similarly, phi can move from 4 to 2, phi to 4 to 2 in this direction, and thus reach the Pacific Ocean. So as you can see, we can reach both oceans from phi, so it has been marked as an answer. Whichever, all the cell values in parentheses are part of the final answer. Similarly, let's see why some of the cell values are not part of the final answer. Um, for instance, 4. From 4, you can move to 2 and then reach the Pacific Ocean. But to reach the Atlantic Ocean, it has to either go from 5 or 7, which are greater than its height values, so water cannot flow in those directions and it won't reach the Atlantic Ocean. We can check for this also. It can move from 4 to 2 to 2, reaches Pacific Ocean, or reaches 4 to 2, can't move in this direction, 4 to 2 to 3 cannot. So as you can see, 4 has no way. If we start from 4, there is no way of reaching the Atlantic Ocean, so it is not marked as a final answer. Now the catch, or one of the way of optimizing this, so the first thought, maybe a kind of brute force solution, would be to start depth first search from every cell in this matrix and check if we can reach the edges, right? Edges meaning the, yeah, the top edge, the left edge, the bottom edge, or the right edge. We could check that for all cell values, and we'll have our answer. Either that, or we can only check. We can either that, or a better way of doing this is that we start the depth first search from every value on the edges and see what is the maximum cell values that we can reach. Meaning we can, let's check, we'll check if the ocean, where the ocean water can reach maximum into the matrix. And now the equation is reversed. Now we'll have to see, now what, when we are flowing, when we are checking from inside the matrix to the ocean, water will flow from cells of higher heights to lower heights. Now when we are checking in the reverse way, we are checking how far can the ocean water reach into the matrix starting from the edge. The water will start, we have to check paths where the height, where the height will go from a lower height to a larger height because it's reversed. Basically, when we start inspecting from the edge, a valid path would be from 2 to 4, or 2 to 3, or 2 to 6, or 2 6 7. What's not, yes, this is not, this won't be a valid path. When we start inspecting from 3, this 3, we cannot move to 2 because now the equation is reversed. Because we are moving from the edge into the grid, we are looking for paths in which the cell height goes from a lower height to a larger height. That's probably the only catch in this problem, that we should only do depth first search for cells on the edges of this grid, and not do the depth first search or breadth first search, whichever algorithm we like, for all the cell values, because the um, uh, matrix could be actually, it's not very large. It's they're saying it's MNN will be less than 150. Either way, it would still make more sense to start inspecting from the edges, because the number of times you will call the depth first search routine will be reduced. With that, this is a very once you figure this out, how once you figure out the approach for this problem, it really is just depth first search, repeatedly applying depth first search or breadth first search, whichever you like. I tried both. Somehow my time limit was getting exceeded on breadth first search. I think it should still work. I mean, logically it should still give you the right answer, but it was timing out on Leetcode. I'm going to be presenting the depth first search solution. Let's get started. I'm going to be using a struct. Struct, for people not familiar with struct, it is just like it's a class. You can imagine it to be a class. um, I'm going to be working with I'm going to be declaring, this is going to be a long solution, guys. I'm going to be declaring a node to represent the cells of the matrix. Just I like thinking of the problem in terms of nodes. I'm going to be declaring it as hashable because I'll be using a set to store it, giving it x and y. These are just a node is simply you simply used to represent cells in the grid, nothing else. Writing a constructor. This is the initializing constructor for it. Cool. Now I'm going to start by writing the depth first search routine, so that after that we can immediately move on to the main Pacific Atlantic function. So let's see what all will we need. We'll need a source, as we usually do with depth first search methods. We'll need the original matrix. This is just the original matrix. We'll need a visited set, as we usually do with depth first search routines, which I'll use for which I'll use a set of nodes. Please ignore the in out. It's just Swift keyword to pass parameters by reference and not value. If you're not familiar with passing by value or reference, you can ignore it. You just have to concentrate on the part that this is the visited set of nodes, and we'll maintain a boolean 2D array of for two 2D boolean arrays, one for Pacific Ocean, one for Atlantic Ocean, to maintain which all cell values have been visited by traversing for the respective ocean. Meaning, if I'll have for every ocean, I'll have a Boolean 2D array where I'll just mark it as true or false or false. Like, sorry, this will be false. No, actually, uh, I mean, I'm just saying that it will mark all the values to see if a particular cell value can be reached by doing depth first search only by this ocean. So we'll have one, sorry, I'm not explaining that well, but we'll have two 2D Boolean arrays, one for Pacific, one for Atlantic, and it will represent the cell values that we can reach using depth first search for the respective ocean. And then we'll check cell values which have true values in both the booleans. You'll understand as we go along. Okay. uh cool, I'll proceed. This is just going to be normal depth first search. Insert the source in the visited set, extracting the x and the y. Okay, now which are the directions in which we can move? We have 4 directions. This would be left, this would be down. Okay, so we have to check, we have to move in every direction. What's the new directions coordinates? Let's check if these new coordinates are within the dimensions of the matrix. There shouldn't be an inequality here. If it is within the matrix dimensions, let's say the neighbor is, if we have not visited this neighbor yet, and this is the magic part. So we have to check if water is flowing from lower to higher values, if since we are starting depth first search traversals from the edge of the matrix. So just check, this is the height condition, this is just the height condition. the height of the new neighbor should be greater than, this is the new neighbor, should be greater than or equal to the source from which we are coming. And if these conditions are satisfied, we'll just do DFS. This is just the normal DFS routine, guys. The neighbor will be the new source, pass the matrix, pass visited, ignore the ampersand. It's just, it's about, it's an in out parameter, that's why I have to do that for passing it by reference. And actually ocean also needs to be in out, so I will, cool. With that, we are ready to move on to the main routine. Putting in some regular empty checks. We just don't want to work with an empty matrix. If we do get an empty matrix, we'll just return an empty array. Oh, sorry. Okay. This is the Boolean 2D array, declaration of the Boolean 2D array for Pacific Ocean. The syntax for declaring 2D arrays in Swift is a little convoluted. I'm sorry if it looks complicated, but it's basically just declaring a 2D array of the same size as the original matrix, but with Boolean values. Initializing everything as false, it will be true if the Pacific Ocean waters can reach that particular cell. Let me just increase this area. Okay. Cool. Let's do the same for Atlantic. Okay. Declaring a visited set. Now let's do Pacific Ocean first. Pacific Ocean is along the left and the top edges. So for I in 0 less than matrix 0 dot count, we will keep refreshing the visited because we want fresh DFS results as we start from every node. As you can see, the row is fixed, meaning this is the top edge, and we'll keep doing DFS with this source, this matrix, visited, and Pacific. So this, after this step, we'll basically have Pacific will hold true for all cell values that can be reached if we start traversing from the top edge, meaning 1, 2, 2, 3, 5. So for instance, 2, this will become true, this will become true, this will become true, all of these will definitely become true, and then 3 will become true, 2 will become true because 3 can be reached from 1, this 2 can be reached from 2, and so on and so forth. Let's do this for the left edge, I guess I can start copy pasting now. Proceeding with the left edge. Now, if you're thinking that the 0, comma 0 node will be inspected twice, you're right. We're just not going to handle that case. I don't think it's worth the effort. It's fine. Shouldn't add to the time complexity too much. Uh, cool. Let's move on to the Atlantic Ocean. For let's use J for this. So as you can see, this is the right edge. Sure. Let's just copy paste this. For the bottom edge. Cool. So we have our both our Boolean arrays, Boolean 2D arrays for the Atlantic Ocean and the Pacific Ocean, which indicate the cells that can be reached from the ocean, from the matrix edges into the matrix. Now we'll just find the intersection of these two Boolean arrays, and that will be a result. So let that result be just declaring, initializing this. We'll be returning this result. Since the dimensions of the matrix are equal to the dimensions of the Boolean arrays, we just check if the respective cell could be reached by both oceans. If yes, we will add the coordinates of that cell to our result. And that's it. We're done. Just to reiterate, the what we have done is we have created two Boolean 2D arrays, for one for every ocean, to represent the cells that can be reached by the specific ocean by following the constraints of the problem. And then we have finally, to get the result, we have just um, calculated the intersection of the two Boolean arrays. Cool. Let's just inspect the code once and see if I missed anything, because this was such a large code. Okay. Yeah, I made a mistake here. This should be J comma. Oh wow, made a major miss. We need to mark that this cell has been successfully visited by this ocean, right? Actually, our solution will not work at all without this line of code. Yeah, I think everything else looks fine. Let's just run this code and check if it works. Okay, that worked. Cool, guys. Not the fastest of solutions, but it works. If you can think of any optimizations to my code, please do leave them in the comments. Until then, good luck. Bye.